1-5, angle relationships. You already know a lot of this stuff anyway. Show me what a vertical angle looks like. Vertical angles, not a vertical line. Vertical angles. No. Right? Vertical angles always make an X. You knew that. You just didn't know what I was asking. You knew that. Vertical lines are this way. You guys are good on that, but that's not what I wanted. Adjacent angles we already talked about. What did I tell you helped you remember adjacent angles? What did we say they were? No? Okay, I'll just tell you. Adjacent angles, remember we said were next to. They were right next to each other, right? We talked about that a couple days ago. Linear pair make a line, right? And then vertical angles make an X, okay? You guys kind of already knew all that, but we're going to make it super proper now. So adjacent angles, angles in the same plane that have a common vertex and a common side, but no interior points in common. What that means is angle 1 is literally right next to angle 2. They're touching. Does that make sense? They don't overlap, but they're touching. So angle 1 is adjacent to angle 2, next to, something like that, all right? Linear pair, adjacent angles whose non-common sides are opposite rays. Angle 1 and angle 2 form a line 180 degrees, right? So measure of angle 1 plus measure of angle 2 equals 180. There's m's and an equal sign because we know the 180, okay? I don't think you have, oh, you do. You have that, just kidding. Vertical angles. Two non-adjacent angles formed by intersecting lines. The vertical angles are congruent. So angle 1 is vertical with which one? Angle 1 is vertical to angle 2, which means they're congruent. Angle 3 is vertical to angle 4, which means they're congruent. Vertical angles are congruent. Okay? That's what it says down here. Angle 1 congruent to angle 2, angle 3 congruent to angle 4. There's no m's and there's no equal sign because I don't know what they are. I just know they're the same. Did I lose anybody anywhere? Pretty easy, right? You already kind of knew that. Okay? Well, catch up. Oh, gracious. Okay. Complementary angles. Complementary means they add up to 90. Supplementary add up to 180. To help you remember that, C comes before S in the alphabet, 90 comes before 180, mathematically. Okay? So, complementary angles are two angles whose measure add to 90. For example, this picture over here, measure angle A plus measure angle B equals 90. I know what they are, 60 and 30, right? What's 60 plus 30? 90. So these are still complementary, even though they're non-adjacent. Do you see what I'm saying? These two, how do I know these two are complementary? The little box, right? So I know that those make 90 degrees. Measure angle 1 plus measure angle 2 equals 90 as well. These are adjacent. That's fine. They can be complementary. These are non-adjacent. They can still be complementary. They don't have to be adjacent to be complementary or supplementary. Okay? And then supplementary are two angles whose measures add up to 180 again, but this time instead of 90, it's 180 because it's supplementary. What's 120 plus 60? 180. So measure angle A plus measure angle B equals 180. And again, I have an equal sign with a number, so I need m's. On this one, angle 1 and angle 2 make a line, so they're linear, so they add up to 180, so they're supplementary. Measure angle 1 plus measure angle 2 equals 180. What I want you to get is that whether they're adjacent or not, they can still be complementary or supplementary. They don't have to be right next to each other, adjacent, to be complementary or supplementary. Okay? Did I lose anybody? All right. Perpendicular lines, lines that intersect to form four right angles. This symbol right here, if you didn't know that before today, is perpendicular. It looks perpendicular, doesn't it? So it is, okay? A lot of times on a test or a quiz, you might have a symbol like that, and if you don't know what it means, you can't really answer the question. So make sure you understand that that means perpendicular, okay? Even though we're not there yet, parallel is that. We'll get there, but I just want you to understand the difference, right? This is perpendicular and it looks like it. This is parallel and it looks like it, but we'll get there another day. So if this is 90, what's this have to be? 90, because they make 180. What's this have to be? 90, 90, right? It forms 4 right angles, perpendicular lines. Are we okay? Okay. Assumptions you can make and not make. You cannot assume by just looking at a picture that something's perpendicular. For example, if I were to draw this, pretend that looked better. If I were to draw that, it looks like they're perpendicular, but what if this was actually 90.2 degrees? So how would I know they're perpendicular without guessing? What would they have had to have drawn? The little box, right? The right angle. Then I'm not guessing. Does that make sense to you? So even if something looks that way, you can't assume that it is, okay? Congruent, same thing. If I have this angle here and I have this angle here and they look the exact darn same, unless they have what, I can't say that. What would I have to have on those two to say it? The little arcs, right? If I have that, now I know it. You can't guess, okay? Equal, same concept, right? Acute, right, and obtuse angles. Remember on the homework the other day where it's numbers 75 and 76 and you drew an angle on a coordinate system and we said it was acute by just kind of looking at it? Do you guys remember that? Okay. That's okay to do. That's okay to look at it and guess. But when we get to a couple pictures here in a moment, you'll see that you can't assume it's acute, right, or obtuse. What I mean by that is, you know how they use the same picture over and over and over again in your book? So like one picture, but like 10 questions. So they don't make sure that the picture's drawn to scale. That's what that means. So if they give you a picture like this, and you said angle 1 was 115 degrees, does angle 1 look like 115 degrees? No. So on one hand, that would be a hint to me that like maybe I screwed that up. But on the other hand, if you checked your answer with me and I was like, no, you're right, they just didn't draw the picture to scale, then you're okay. It's typically not this obvious. Like angle 1 maybe here could be, maybe you would get 10 degrees. That doesn't look like 10 to me. It looks kind of like, I don't know, maybe 30. Do you see what I'm saying? So that's what I'm trying to let you know. Your book never draws anything to scale. So in my opinion, if you got angle 1 was 115, I think maybe something went wrong. But if you got angle 1 was 10, that's okay. They didn't get out a protractor and a ruler and a compass and everything and make sure that it was 10 exactly. Do you guys get what I'm saying? Okay. These are things you can assume, which is things that we've been assuming anyway. Collinear, if they're on the same line, they're collinear. Nobody has to say anything about that, okay? Coplanar, intersection, betweenness, all this stuff, you can assume. Basically, as long as you understand this, you're fine, okay? All right, name an angle or angle pair that satisfies each condition. If yours is hard to see, look at mine. 2 acute vertical angles. So we have to find vertical angles that are acute. When they just said we can't assume things are acute on this picture, we kind of have to. We don't have a choice. You see what I'm saying? So just kind of be careful of that. So I'm going to give you one angle, and I want you to give me the other one. I said angle BFC, okay? BFC, find that angle. Would everybody agree that that's an acute angle? The 60 is going with the C. It's easier to see in yours, right? So I don't know what BFC is, but I'm confident it's less than 90. Is everybody okay with that? So give me another acute vertical angle with BFC. It's got to be vertical to that, but also acute. DFE or DFG would be fine. DFG or DFE, either way. Do you guys all understand that those are 2 vertical angles? Do you get that they're both acute? Perfect. Looks good to me. I really didn't know any other ones. I think that was kind of it. Okay. Number 11, 2 complementary, that means what now? Add up to 90, right? 2 complementary adjacent angles. So I need 2 angles that are adjacent, right next to each other, that add up to 90. Hold on. ADF by itself already is 90. So complementary means 90. If I had said supplementary, that's what we would have said. Okay, so try again. We want 2 right next to each other that add up to 90. Yeah. DEG and DFG. DEG is right here? Is that what you meant? Oh, say it again. GED is right here as well? Are you trying to say this one? Okay, that would be EDG would be this one, okay? And GDF would be that one. I think that's what you're trying to say, right? Okay, so here's how he knew that. Does everybody see the right angle right here? Okay, if this is 90, that and this make 180, right? So if that's 90 there, then these two have to make 90 as well, right? So I need FDG, and I'll say GDE. Does everybody get that? Two supplementary adjacent angles. Sam, tell me again what you said the first time. ADF, FDE. Very good. Does everybody see that ADF and FDE make a line? When they're attached to each other, they're next to each other, they're adjacent. So she said angle ADF and angle FDE. That would be supplementary because they make a line. Did I lose anybody there? We could have said another option on that one. We could have said, look up here when you have a second. Supplementary again means they add up to 180. So adjacent angles, if I said CFB, what angle would be supplementary to CFB? BFD. That would be another option. Do you see what I'm saying? There's a couple more you could do if you wanted to. Okay, so not just one answer all the time. Did I lose anybody? All right. Find the value of the variable. Find x. We're going to ask ourselves all year long, what's their relationship? What's the relationship between this angle and this angle? Give them a name. This one? This one. Say again? I heard it somewhere. Yes, go before that. What's their name? Are they vertical, right? These two are vertical, which means they are congruent, the same, right? This one's the same as this one. How do I write that in math? How do I make that an algebraic statement? 2x minus 10 equals 120. Excellent. Does everybody understand that? They were vertical angles, which means they're congruent, which means set them equal. Solve for x. Everybody should be able to solve for x there. So you add the 10, you get 2x equals 130. Divide by the 2, x is 65. Is that what they asked us for? Yep, they said find the variable. We did. I'm sorry, I can't hear you. Say it louder. What's he say? I can't hear anything over that. What did he say? This is not degrees. X is 65 is not degrees. Oh, got it. Yeah. Okay, good. Got it. Yes, those little circles are degrees. Got it. X itself is not degrees, but when you plugged it back in, you would get however many degrees this is, which it should be 120, right? Anybody lost it all? Pretty easy. Okay. Find the value of each variable. What can you not assume here? That they're all 90. We don't know that. It looks like it, but we don't know that. What if it's 89.2, right? What do we know? Yeah, a bunch of them add up to 180, which means they're, what fancy word for that? Supplementary, right? So these two, do they make a line? Yeah, so if I wanted to, I could add them up, set them equal to 180. Why don't I want to do that? Because they're two different variables. That's a lot harder. It's doable, but it's a lot harder. We don't want to do that. Yeah, so we could do these two, couldn't we? Those two make a line, so they add up to 180. And so do those two, right? So we're going to say 2y plus 50 plus 5y minus 17 make 180. And we're going to say 7x minus 248 plus x plus 44 make 180. Pretend that's fit. Okay? Find x, find y. I'm going to wait for you to try that first. If you can't get it, I'll do it for you. But by now, you should be pretty okay at finding x and y. Okay? Algebra 1 stuff. Since I'm recording it, I'm going to actually solve for x and y so people who are watching can see that, but hopefully you guys are getting it right. We also have vertical angles, correct, but this angle is vertical with that one. It's an x and a y again, so that doesn't help me. And this one is as well, x and y, so that didn't help me. It's still true, but in this picture it didn't help. Does that make sense? I can't set an x and a y equal to each other. I wouldn't get anywhere. Does that make sense? I could set up two different equations with two different variables, but that's an Algebra 1 skill that we probably don't remember, so I'm going to stick with just the x's together. Okay? So obviously, what I typically try to do is I try to combine like terms before I move anything. So what's 2y and 5y? 7y. And what's the 50 minus 17? Say it again. Equals 180. What do I do to both sides? What? Subtract 33. So you get 7y equals, oops, what? 147. Divide by 7 and you get 21. Everybody in here get 21 for y? We're okay? Great. What do you guys get for x before I do it? Should get 48, right? So combine like terms, we've got 7x and a 1x, that's an 8x. What's negative 248 plus 44? Negative 204 equals 180. Now we can combine, add the 204 here, add the 204 here. So 8x equals 384, divide by the 8, x is 48. They asked us for the variables, we found the variables. Are you guys okay? Okay. They didn't ask us to. Nope. They just said find the value of the variables, and I did. If they had given these letters, like, I don't know, A, B, C or something, and they said find the measure of angle A, B, C, I would have substituted it back in. But they didn't ask me to, so I'm not going to. Okay? Anyone still need that page? All right. Here we go. Number 27. The measure of the supplement of an angle is 40 more than 2 times the measure of the complement of the angle. Find the measure of the angle. It's a lot of vocab, right? In geometry, if you don't know your vocab, it's going to be almost impossible for some questions. In algebra, you could just look at the question and be like, oh, I think they want X. I'm going to find that and not even read. On geometry, it's not an option, okay? So slow it down a bit. The measure of the supplement of an angle. When you hear supplement, what do you think? Probably the 180 stuff, right? Supplementary. So for example, if I say my angle is 30, I want to know the supplement of it. What's the supplement of 30? 150. Whatever makes it add up to 180 is called the supplement, okay? So that means you guys took 180 minus 30, and that's how you got the 150. Does that make sense? Obviously, I totally made those numbers up. It doesn't help me here, but the supplement of an angle, this is how you write that. The supplement of an angle. I don't know the angle, I'm calling it x. Its supplement is going to be 180 minus x. Do you guys understand that? Then they said is, I already wrote it. What's is mean? Equals. They said 40 more than, how do you write that? 40 plus 2 times, right? The complement of the angle. The complement of the angle, how would I write that? If the supplement of the angle was 180 minus x, what's the complement of the same angle? 90 minus x, right? So again, if my angle was 30 and you're the complement of mine, what are you? 60, because you took 90 minus 30. That's how you got the 60. Same thing. 90 minus I don't know. Does that make sense? Whenever you multiply by more than one thing, you have to use parentheses. We're going to have to distribute that too. Okay? So 180 minus x equals 40 plus what? Distribute. What's 2 times 90? 180 minus 2x. Very good. So again, before I move anything from the left to the right side or vice versa, I always combine like terms first and then I move. So I'm going to keep the 180 minus x just like that. What's 40 plus 180? What's 40 plus 180? 220. I still have the minus 2x. From here, you can do whatever you want. You can subtract 180, you could add x, you could subtract 220, you could add 2x. For me personally, I prefer to work with the variable first, and I prefer to keep it positive. So what would I do? I would add 2x and add 2x. Do you guys get what I'm saying? You don't have to do that. That's just what I do, okay? So 180 plus x equals 220. What do you do to both sides? Subtract 180 and we get 40. The angle they're talking about is 40. Did I lose anybody? Questions at all? All right, last page. Okay, determine whether each statement can be assumed from the figure. This is just a yes or no. All right, look at angle VYX. The measure of angle VYX, so find that, kind of trace it, right, is 90. VYX, is it 90? Can I assume that? Yes, if you look, VYX is right here, right? And there's the little right angle box. So I'm not even assuming, they just kind of told me it was in the picture, right? That's a yes. Angles TYW and TYU are supplementary angles. So find them, right? TYW is right here. TYU is right here. Are they supplementary? Do they add up to 180? Do they make a line? Yes. Do you guys get that? If they're adjacent, supplementary means a line. They don't have to be adjacent to be supplementary, but these were adjacent and they made a line, therefore they were supplementary because they added up to 180. Does that make sense? Okay, they don't have to be touching to be supplementary. They have to be touching to be adjacent. Okay. Angle VYS, so let's find that one. VYS is right here. And angle WYV, WYV is right here. So these two, can I assume they're the same? Nope. What would they need if I were to assume that? The little arcs, right? But they didn't have that. I put one there just so I knew what I was talking about, but they didn't have that. Angle VYW and TYS are adjacent angles. So VYW is this one here already, and TYS is this one here. Are they adjacent? No, right? VYW and VYS are adjacent, but the two that they asked us about are not. Did I lose anybody anywhere? Anybody have a question at all? Are you sure? Okay.